Okay, we are live. So, hello everyone. Welcome to Practically. We bring learning alive. Alright. So, as you all are aware that we have started this Term-2 one-shot where we will be discussing or covering the entire chapter in a 1 hour, 1 to 1.5 hour or 2 hours, correct? So, today for class 9, this is the first mathematics class for you. So today we will be discussing the chapter polynomials. Okay. So let us start with the chapter polynomials. We will cover the entire chapter. We will see all the subtopics and also example for each. Okay. And also I hope the screen is clearly visible and I'm audible enough. Alright, so yes, let's begin the session. So before, let me introduce myself. I'm Sai Pranati and by now you will be familiar that I'll be teaching mathematics, correct? So yeah, before like starting the session, let us once go through the schedule, what schedule of one shot and sample papers. So for one shot for class 9, the time slot is 6 p.m. to 8 p.m. for math and science. So it started on 1st Feb and it will continue till 24th Feb, and after one shot series we will be having sample papers of the same. So we will be discussing sample papers according to the CBSE guidelines. That slot is also from 6 p.m. to 8 p.m. itself. So we have 4 sample papers, 2 of math and 2 of science. Okay. Next is coding. So coding for class 9 computer science. So these are the dates on which coding classes will be held, and this is the time slot, that is 8 to 9:30 p.m. Alright. So I hope the schedule is clear. So people who want, you can take screenshot. So this is for one shot, this is for sample papers, and this is for coding. Alright. So now let's begin the session. So let us see what topics are we going to cover today. Okay, we will be seeing the introduction to the topic, that is introduction to polynomials. What is a polynomial? Okay, next we will see polynomials in one variable. We will see classification of polynomials, what are zeros of polynomials and how to find zeros of polynomials. Next we will see what is remainder theorem and factor theorem. Next we will see the algebraic identities. So in the syllabus, like the proof of remainder and factor theorem is removed. So I will be not discussing the proof in today's session. We will be just seeing what does the remainder theorem and factor theorem says and also the problems on it. Okay. All right. Let's begin. So x square plus y square plus 2xy. What is it? What exactly it is? This is an example of an algebraic expression, and I'm sure you have studied algebraic expression in your class 8, correct? So in our previous classes, we have studied about algebraic expressions and all the terms related to it, right? We know what is variable, constant, term, expression, exponent. So we have learnt many terms. Now we will recall what all the terms related to the algebraic expressions. Okay. So first is variable. Now, by now you must be aware what is a variable, correct? Zombie shots. Hi zombie shots. Okay, so what is a variable? Variable is denoted by a symbol that can take any real value. Generally, any letter of an alphabet can be used to represent it. So what is variable? Generally, when I say variable, everyone will think of x, y, a, b, c, correct? That is exactly correct. So variable is denoted by a symbol that can take any real value. So here in the example, a plus b equals to 20. So a and b here are variables, correct? A, b here are variables. Because when a plus b equals to 20, if I put a 10 and b 10, then also it is 20. if I take A is equals to 2, B is equals to 18, then also A plus B equals to 20, correct? So what did you observe here? The variable is a symbol that can take any real value. Alright, next, constant. So this is simple, right? In algebra, a constant is a number on its own. Nothing so, like complex in understanding it. What is a constant? It is a number on its own. All the numbers 23, minus 31, 1000, 1500, minus 2000, all these are constants. Next, degree of the polynomial. A polynomial's degree is the highest or the greatest power of a variable in a polynomial equation. Okay, so again let us see what is meant by the statement. A polynomial's degree is the highest or the greatest power of a variable in a polynomial equation. Okay, zombie shots say 7. Okay, alright. So wait, let us see. So here it is 6x power 4 plus 2x cube plus 3. This is our example given. So what is the variable here? Can anyone tell me in what variable is this algebraic expression? It is in the variable x, correct? So what is the highest power of x here? 4. So we say that degree of the polynomial is 4. Okay, and zombie shot you've given 7. I'll tell why 7 is not correct, okay? You cannot add this 4 and 3 because these two are separate terms and you just cannot add. The highest power or the greatest power of the variable in the polynomial equation is known as degree of the polynomial, okay? Yes, we will definitely try to teach in Hindi as well. We are thinking of it. So for today's session, please make sure like you understand. If I teach in English, I'm so sorry. All right. Okay. So what is this? Degree of the polynomial is, the given polynomial is 4. Now, let me give you another example. Suppose if I take x power 5 plus 2x power 6 plus x cube is equals to 11. Now, in this given equation, what is the degree of the given equation, or what degree is it? Can anyone tell me? Comment in the answers like what is the degree? So just type the answers in the comments. Very good, very good. It is 6. Zombie shots, you've given correct answer. It is 6. Why? Because it is the greatest power of the variable x in the given equation. So yes, your answer is correct. Next. So we have seen what is the variable, what is the constant, and also what is the degree of the polynomial. Next, let us see what is coefficient and what is the term. A coefficient is the multiplicative factor in some term of a polynomial, a series, or any expression. It is usually a number but may be any expression. So again, let me take an example here. I have taken 5xy. So if I take 5xy, so if what is the numerical coefficient of the given term? The numerical coefficient is 5, correct? So that is what it is given. The coefficient, or you can say numerical coefficient is of 5xy is 5. Now the coefficient of minus 23x power 5 is minus 23, correct? So this is about coefficient. Next, term. What is the term? It may be a single number, positive or negative, a single variable, a letter, several variables multiplied but never added or subtracted. So always remember, there shouldn't be any mathematical operator of like plus or minus in the terms, okay? Now for ABC, so if I take the example for ABC, this is considered to be as one term, okay? And minus 100x cube, this is also considered to be as a term, one term, Okay? Alright. So I hope it is clear. It's clear like what is coefficient and what is a term. Now let us see what is expression. Now expressions you already studied in your previous classes. What is an algebraic expression, correct? So we'll just recall it. Expressions are mathematical statements that have a minimum of two terms containing numbers or variables or both connected by an operator in between. Now if I write 5xy minus 2y. Now these two terms are connected by a mathematical operator, correct? So this is an example of an expression. So can anyone tell me example of an expression? Please do type in the comments. Oh, okay. Alright, so let us see. If I take x square plus y square plus 2xy. So this is also an expression because there are three terms, correct? There are three terms and there is a mathematical operator which is which connects all the terms, that is plus, correct? So, okay, zombie shots 10af plus 2bk, very good. 10af plus 2bk, very good. This is also an expression. Very good. So now we have seen all the terms related to algebraic expressions and polynomials. Now let us step into another topic, that is polynomials in one variable. So what exactly does it mean that polynomials in one variable? The name itself says, right? There is a polynomial which has only one variable in it, either x or a or b or c or y, p, anything, right? Now, x square plus 2x, x square plus 2x. So, this algebraic expression or this polynomial has only variable x, correct? Next, 5x cube plus 3x square plus 21x. So, again, let us write here 5x cube plus 3x square plus 21x. So, this also has only one variable. Same goes with x plus 51. It has only one variable x. Now, all these above algebraic expressions contain only one variable x and have whole numbers as exponents of the variable. This part of the definition is very important. Whole numbers as the exponents. So, in these examples which we have seen, there is no fraction, right? All the powers of x is a whole number because here x2, here it is 1. Here the power of x is 3, here it is 2, here it is 1. So there is no fraction or decimal or anything, correct? So all these above algebraic expressions contain only one variable x and have whole numbers as the exponents of the variable. These expressions are known as polynomials in one variable. Okay. So to define one as a polynomial or to consider one as a polynomial, we have to see these two. That is, it has only one variable and also the exponents are only whole numbers. Okay, I hope it is clear what is the polynomial in one variable. Next, let us see a few examples. So, if I give you 3xy plus 2x cube, can you tell me if this is a polynomial in one variable or not? Just type the answer in the comments. So, no. So, it is not a polynomial in one variable because in the first term itself there are two variables. So, how can we tell that it is a polynomial in one variable? It is not, correct? So, not a polynomial in one variable. Okay, so the other one, if I take 3p power 0.3 plus p 2p. Now, if I give this algebraic expression, can you say that it is a polynomial in one variable? Come on, type the answer in the comments and tell me if it is can be considered as polynomial in one variable or not. So, no, this also cannot be considered as polynomial in one variable. Why? Because here the exponent is 0.3 and what have we studied in the definition? We have studied that whole numbers should be the exponents of variable, but in this case it is 0.3 which is not a whole number. So this is also not a polynomial. Alright, so you have seen what is a polynomial and what cannot be considered as a polynomial in brief way, correct? So let us see an example. Now consider the algebraic expression x plus 1 by x. Is this an example of polynomial in one variable? Come on, you have to answer this. I have just told. So just spend 30 seconds of your time and tell me if x plus 1 by x can be considered as a polynomial. So please do drop the answer in the comments. Alright, so come on, let us do it. So it is x plus 1 by x, right? So what is the power here? 1. But if I write it like x plus x power minus 1, of course, right? I can write 1 by x as x power minus 1. So here again, if you consider the power is or the exponent is minus 1. So though it has only one variable, we cannot consider it to be a polynomial because what we have studied, the exponent can be only a whole number, right? So yes, this is about polynomials in one variable. Now, let us see what is not a polynomial. So till now we have studied what is a polynomial and we have just seen two examples where we have come to a conclusion, okay, that is not a polynomial, correct? Now let us understand what is not a polynomial in a detailed way. Polynomials cannot contain division by variable. So what does it mean? I cannot say that 2 by x is a polynomial. 2 by x is not a polynomial. Why? In the denominator, it has variable. So, polynomials cannot contain division by a variable. Okay? Next, polynomials cannot contain negative exponents. Yes, obviously, we have just seen now. So, if I take x power minus 4 plus 2x cube, then this is also not an example of polynomial because here the power is minus and polynomials cannot have negative exponents. Next, polynomials cannot contain fractional exponents. Yes, obviously. So here let us take q power 1 by 3. So if I say q power 1 by 3, what does it tell? The exponent is a fraction, correct? So we see that this is also not a polynomial. And last, the variable cannot be inside a radical. So what is the radical? The root. Okay, if I write 2 root x, it is also not a polynomial. Okay, why? Because this variable is inside the radical. And also if you simplify, I can write this as x power 1 by 2, which is again the exponent is fraction. And we know that polynomials cannot contain fractional exponents, correct? So, what does this mean? the variable cannot be inside a radical. Okay, so these are the things you have to remember to check whether the given expression is a polynomial or not. Okay, now let's see few examples. Check whether the following are polynomials in one variable or not. So the first one, x of 2x plus 3. So let us simplify it. How can I write 2x square plus 3x? Of course, it is a polynomial in one variable. Why? It has only one variable and the exponents of it are whole numbers, correct? So yes. Next, x plus 1 plus 3 by x. So again here is a catch. So if we take this 3 by x, we know that the variable, there shouldn't be a division by a variable, correct? We have just studied polynomials cannot contain division by a variable. Okay, right, so this is no. So just let me write no instead of writing it completely. So it is no. Next, 3 by 2x square plus 4x. So again here, let us see if it has only one variable. Yes, this complete expression has only one variable x. And what about the exponents? Here it is 2, here it is 1. So yes, it is a polynomial in one variable. Next, root 5x plus 3x square. And what have we just studied about radicals? The variable shouldn't be inside a radical, correct? So this is a no, because I can write this as root 5 into root x plus 3x square. So no, this is not a polynomial, right? Next. Now let us see classification of polynomials based on number of terms first, and then we'll go to the classification based on the degree of the polynomial. Okay. Polynomials classification based on number of terms. So first, monomials, binomials and trinomials. So what does this mean? Mono means one, correct? So it has only one term. Suppose 5x, 21, 51, xyz, pqr. So these are all monomials because all has only one term, correct? So single term, it's nothing but monomial. And what is binomial? The name itself says bi means 2. So 2 terms. So let us write 5 plus 3n, m square plus 45m. So these two are the examples of binomials. Why? They have 2 terms. Next is the trinomial. What is the trinomial? Tri means 3. So it has 3 terms. A plus B plus C. X square plus Q square plus Z square. So these two are the examples of trinomials because they have 3 terms. So I am just writing it here. 3 terms is trinomial. When it has only 2 terms, it is a binomial. When it has only a 1 term, it is called as monomial. Okay. Right. Yes. Hi Lakshmana Prabhu. I hope you're doing well. Okay. So this is a classification of polynomials based on number of terms. Alright. So now, but there is also another classification of polynomials. What is that? It is classification based on degree. And what is the degree of the polynomial? We have already studied. It is nothing but highest power or greatest exponent in the given expression or variable in the given expression. So if I write x power 5 plus 2x power 4, what is the degree of the given expression or given polynomial? It is 5. Correct? So now we know what is the degree of the polynomial. We have already studied but just have repeated it. So now we will see the classification of polynomials based on the degree. So first is the linear polynomial. That means degree of the polynomial is 1. Now if I say degree of the polynomial is 1, can you give any example of it? Please do type in the comments. Tell me an example of a linear polynomial. Example of a linear polynomial. Just type in the comments, okay? Yeah. X plus 8. Okay, very good. Good. Okay, x plus 8, a simple example, and we can just take anything, n plus 25. So, here what do you see? The exponent of x is 1 and it is the greatest exponent in the given polynomial. So, we see that 1 is the degree of the polynomial. So, yes, n plus 25 is also same case, that is a linear polynomial. Now, let us go to quadratic polynomials. What is quadratic? It is nothing but degree is 2. Degree of polynomial is 2. So, let me give you an example. M square plus 2m plus 3. So, this is an example of a quadratic polynomial. Why? Here the degree is 2. Correct? The degree of the polynomial is 2. Now, can you all give me one more example of quadratic polynomial? Just type the answer in the comments. And if you cannot type the square, just type square, okay? I'll understand. Alright, let me give you another example. Okay, t square, okay, 5t square plus 7. This is an example of a quadratic polynomial. Okay, Lakshmana Prabhu has given example, x square plus 2x plus 8. X square plus 2x plus 8. Yes, very good. So, these are the examples of quadratic polynomials. Why? Here the degree is 2. Now, let us see and understand what is the cubic polynomial. So, what is meant by cube? 3, correct? So, you are right, your guess is right. That is degree here is 3. So, let me give you an example again. X cube plus 3x square plus 3x plus 21. So, this is an example of a cubic polynomial. Now, here you have to just check what is the degree and classify the polynomials according to it. I hope you have understood what is a I hope you have understood the classification of polynomials based on degree as well as based on number of terms. Okay, I got one more example here. X cube plus 2x square minus x. Okay, x cube plus 2x square minus x. Good. Very good. So, now you have understood and you have known the difference between linear, quadratic, cubic and also about monomial, binomial and trinomial. Alright. Okay. Okay. There is also quartic and biquadratic, yes, but then the classification till here is fine, okay? Yeah, because in few books it's also written quartic polynomial, right? I don't know if you have seen this quartic. So, can anyone tell me what is quartic? Biquadratic, define. Can anyone tell me? If you have seen this term, you have to answer. Four. Yeah, degree is 4. Alright. So, but then till here it's fine. You have to just know what is quartic. It's fine. Yes, degree 4. Good. Fine. Very good. Now, there is also something called constant polynomial and also zero polynomial. What is it? Constant polynomial. A polynomial having its highest degree 0. Its highest degree is only 0. It is called a constant polynomial. Good evening, Amit. Good evening. I hope you're doing fine. Next. So, the name itself says, right? It's a constant. There is only constant. So, if f of x is equals to 6, so can I write 6 as 6 into x power 0? Of course, I can write y x power 0 is equals to 1. Correct? So, 6 is an example of a constant polynomial. So, can I tell that all numbers are constant polynomials? Can I write a statement like this? Are all numbers constant polynomials? Yes or no? Yes. So definitely yes. So if I take here minus 19, I can write minus 19 also, minus 19 into x power 0. So in all this, the highest degree is 0. So yes, that is known as a constant polynomial. But here if you're seeing a zero polynomial, what exactly is a zero polynomial? Zero polynomial is a constant polynomial whose coefficients are all equal to 0. The degree of zero polynomial is not defined. Okay. So what is meant by coefficient 0? That is 0 into x power 0. Correct? Or you cannot define this degree, so 0. 0 is nothing but 0 polynomial. Okay. So this is the difference between constant polynomial and a 0 polynomial. Alright. I hope you have understood, and let's go to the next. Find the degree of each of the polynomials. So this is one of the easiest like problem today. So yeah, for the first one, can you all tell me what is the degree? Just type the answer in the comments, okay? A is 6. Okay, you're seeing 6. Okay, this is 5. Yeah, 5. Okay, 5. Good. Next. B is 8. Very good. Here B is 8. And what about C? C is 2. D is 0. Very good. C is 2, D is 0. Why is it 0? 75 x power 0, so 0. So is 75 a constant polynomial? Yes, so the 75 is a constant polynomial. Good. Next. A polynomial in one variable x of degree n is an expression of the form. So here an minus 1, these are all the coefficients, correct? So we can write it as an x power n plus an minus 1 x power n minus 1, so on till a1x to a0. Here it is x power 0. So where a0, a1, a2, so on till an are constants and an not equal to 0. So if an is equal to 0, what will happen? This whole term will be equal to 0 and this will not be a polynomial of variable x in degree n, correct? That is why we say that this is the condition that an not equal to 0. Okay. Now, in particular, if all the coefficients are 0, what have we studied where in a polynomial where all coefficients of 0, it is the 0 polynomial. So, when all the coefficients are 0, we get a 0 polynomial which is nothing but 0. Okay. So, this is just a general form of a polynomial with one variable x of degree n. Alright. Next. Okay, we have already solved this, correct? Yeah, zeros of a polynomial. Now that we have studied what is a polynomial and classification of polynomials, let us understand what is meant by zeros of polynomial, okay? For that, let us do a small activity. So here there is a polynomial 2x square minus 3x plus 1. Let us substitute x is equal to 1. So what will happen if I substitute x is equal to 1 in the given polynomial? Let's do. So f of x is equals to 2x square minus 3x plus 1. F of 1, that is x is equals to 1. What we'll get? 2 of 1 square minus 3 of 1 plus 1. So this is 2 minus 3 plus 1. Minus 1 plus 1, 0. Right? Now tell me what you will get if you substitute x is equal to minus 1 in the given polynomial. Yes, Lakshmana Prabhu, very good. If you substitute x equals to 1, we'll be getting 0. Now substitute x equals to minus 1 and tell me what answer you get. Okay, let us see. Now f of minus 1. So 2 of minus 1 whole square minus 3 of minus 1 plus 1. So what is minus 1 whole square? It is 1. Okay, you got 6. Let us see. So this is 2 plus 3 plus 1, that is 6. Very good. So when you substitute 1 in the given like x equals to 1, you got 0. When you substitute x equals to minus 1, you got 6. But what is 0 of the polynomial? So when you substitute the value of x and you get the answer as 0, then this number is known as 0 of the polynomial. So I can tell that 1 is the 0 of the polynomial or 0 of the given polynomial. Correct? So yeah, 1 is the 0 of the given polynomial 2x square minus 3x plus 1. Yes, definitely yes, Lakshmana Prabhu, you're right. You can say 0 or root of the polynomial as well. But generally we say that root for a quadratic, like not quadratic, I'm sorry, for an equation. Okay? Right. So this is about just a small activity we did. Now we say p of x equals to 0 is the polynomial equation and 1 is the root of the polynomial equation p of x equals to 0. Exactly right. So if we are given a polynomial, equate that to 0 and whichever is like satisfies it, that is the 0 of the given polynomial. Now suppose p of x is equals to ax plus b, a not equal to 0. And we know that ax plus b is nothing but a linear polynomial. Why? The degree of it is 1. Now equate this to 0. Ax plus b equals to 0. So how will I write? Ax equals to minus b and x equals to minus b by a. Now x equals to minus b by a is the 0 of the polynomial ax plus b. Now let us check and see whether it is correct, right? So substitute p of minus b by a is equals to a of minus b by a plus b. A gets cancelled, minus b plus b 0. So yes, of course we got 0. So we say that minus b by a is a it's a root of the polynomial equation. Okay. Next, verify whether, now that we have studied the topic, let us see whether we have understood by applying it in the question. Okay. Verify whether 2 and 0 are zeros of the polynomial x square minus 2x. Come on, first let us do with 2. Okay. What is the given polynomial? P of x is equals to x square minus 2x. We have to check whether 2 is the 0. So just substitute P of 2. Just substitute 2. 2 square minus 2 of 2. 4 minus 4, 0. So we got 0. What that means? It means that 2 is a 0. 0 of the polynomial p of x. Right? Very good. Very good. Now everyone substitute 0 and tell me if it is a 0 of the polynomial or not. 0 is also 0 of the polynomial. Oh, you're very quick. Okay, let us check. P of 0. P of 0. So 0 square minus 2 of 0. 0 minus 0 is 0. So yes, 0 is also 0 of the given polynomial. Very good. Next. Find P of 0, P of 1 and P of 2 for each of the following polynomials. Okay, so let us do the first one, okay? So what is the P of x? P of x is equals to x minus 1 into x plus 1. So if I want to find P of 0, what do I have to do? Just substitute x equals to 0. So P of 0 is equals to 0 minus 1 into 0 plus 1. Minus 1 into 1 minus 1. Now next is P of 1. Substitute 1. 1 minus 1 into 1 plus 1. 1 minus 1 is 0. So 0 into anything is 0. So 0. Right. Next P of 2. So this is 2 minus 1 into 2 plus 1. 2 minus 1 is 1. 2 plus 1 is 3. 3. So did you all get the same answers? I hope you got the same answers. Minus 1, 0 and 3. Correct? Now just do it for the second one. P of y equals to y square minus y plus 1. What do you have to do? You have to find P of 0, P of 1 and P of 2. So I'll just wait for 30 seconds. I hope it's sufficient. So you can at least tell for these two P of 0 and P of 1, right? You got same answer. Very good. Okay, 1 is 2. 2 you got. Okay, let us check. So Lakshmi Prabhu has given the answers. P of, okay, this is y, right? P of y is equals to y square minus y plus 1. So what do we have to find first? P of 0. So P of 0. 0 minus 0 plus 1. So 0 minus 0 plus 1. That is 1. Correct? Good. Next, P of 1. 1 minus 1 plus 1. 1 again. Next, P of 2. So 2 square minus 2 plus 1. 4 minus 2 plus 1. 3. So yes, we have, yes. Good, very good. 3. Alright. So this is easy, just substitution. Now let us see what is the remainder theorem. Next we will move to factor theorem as well. So what is remainder theorems? To understand what is remainder theorem, first let us perform the long division, okay? Now I'm sure you all know how to divide polynomials, correct? If not, please do concentrate, alright? So this is the dividend, this is the divisor, right? Now let us just write 3x power 4 minus 4x cube minus 3x minus 1 divided by x minus 1. Correct? Alright. So just write the dividend here, divisor here. Okay? Alright. So just give me a minute. So I'll write the question there. Okay. Alright. Good. Next. So with what I have to divide to x to get 3x power 4, I have to divide it with 3x cube. Right? So x into 3x cube is nothing but 3x power 4. Okay, you got minus 5. What did you get minus 5, Lakshmi Prabhu? Can you be little clear about it? Did you get quotient as, remainder as minus 5? Okay, did you use the remainder theorem to solve it this quick? Alright. So now, minus 1 into 3x cube is minus 3x cube. Now just do minus, this will be plus. Minus 4x cube plus 3x cube is minus x cube. So take minus 3x. Now what do you have to multiply? Minus x square. So we'll get here minus x cube. Then multiply this minus 1 to minus x square. So minus into minus plus. So this will be plus x square. Yes, ma'am, use remainder theorem. Yes, of course it is easy. Yes. So plus minus. So minus x square minus 3x minus. So same thing again. Minus 4 minus 4x plus 4. So we got minus 5 as the remainder, correct? Yes. Now we will see in the long division, what did we get remainder? This is the remainder, correct? We got minus 5. Now let us see what is remainder theorem. Let P of x is any polynomial of degree greater than or equal to 1. So it should be 1 or greater than 1, the degree, okay? And let A be any real number. Now, if P of x is divided by the linear polynomial x minus a, then the remainder is P of a. So, what does it mean? We will take this only. This is our P of x, correct? So P of x is equals to 3x power 4 minus 4x cube minus 3x minus 1. Minus 4x cube minus 3x minus 1. And what is the divisor? It is x minus 1, correct? So what we have to do? P of a, so that we will be getting the remainder, correct? I am not teaching the proof again because it is not included in the syllabus, okay? So if this is x minus 1 is equals to x minus a, correct? So what will be a here? A is equals to 1, right? Now do P of a. What is P of a? 3 into 1 power 4 minus 4 into 1 cube minus 3 into 1 minus 1. So 3 minus 4 minus 3 minus 1. 3 minus 4 is minus 1. Minus 1 minus 3 minus 1 minus 5. So did we all get the same remainder? Of course, correct? So what you have understood, you need not do the complete long division to get the remainder. You can just apply remainder theorem and solve it. Alright, now that remainder theorem is clear, let us see one example. Find the remainder when x power 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1. Now you know the concept, please do apply it and let me know the answer in the comments. So just substitute, use the remainder theorem, don't use a long division. Okay? Yes, let us see. So what is P of x? P of x is equals to x power 4 plus x cube minus 2x square plus x plus 1. And using 2 is the remainder. Okay, let us see if 2 is the remainder. Using remainder theorem. So P of x minus 1 is the divisor. So just write here g of x is equals to x minus 1. So P of 1 power 4 plus 1 cube minus 2 of 1 square plus 1 plus 1. Alright. 1 plus 1, 2. 2 minus 2, 0. 1 plus 1, 2. So yes, 2 is the remainder. Very good. So we have given the answers. Very good. Keep it up. 2 is the remainder. Next. Factor theorem. Now we are done with remainder theorem. But what is factor theorem? This is also very easy. If P of x is a polynomial of degree n greater than 1 and a is any real number, then x minus a is a factor of P of x. If P of a is equals to 0, it is just the reverse, correct? If P of a is equals to 0, x minus a is a factor of the polynomial. and P of A is equals to 0 if x minus A is a factor of P of x. It's very easy. So I'll just tell you an example here, okay? So here we did not get P of 1 is equal to 0, correct? So we say that x minus 1 is not a factor. But what if we get P of A is equal to 0? Then we say that x minus A is a factor of the given polynomial, okay? So it's also a very easy, no need to again perform long division for this. You have to just apply remainder and factor theorem so as to tell whether it is a factor or what is the remainder of the given polynomial, okay? So here, let us see the example. Examine whether x plus 2 is a factor of this polynomial and also this polynomial. So there are two polynomials given here. First, let us do this one. So what is my P of x? P of x is equals to x cube plus 3x square plus 5x plus 6. And I have to check whether x plus 2 is a factor of. So, okay, g of x is equals to x plus 2. And here what is, what we have to check? P of minus 2. If P of minus 2 is equals to 0, then x plus 2 is the factor. Correct? So this is what we have learned through the factor theorem. Let us just do it. P of minus 2. Substitute minus 2 whole cube plus 3 of minus 2 whole square plus 5 of minus 2 plus 6. It is a factor. Okay, very good. Let us check. So what is minus 2 whole cube? Minus 8. Minus 2 whole square is 4. 4 times 3 is 12. 5 times minus 2 is minus 10 plus 6. Minus 8 plus 12 is how much? Plus 4. Plus 4 minus 10 minus 6. Minus 6 plus 6, 0. So yes, P of minus 2 is 0. Then what does it mean? X plus 2 is the factor of this given polynomial P of x. Now let us do for the second one. Alright, very good. It is a factor for the first one. Correct. Now next. Let us just type f of x here. F of x is equals to 2x plus 4. Okay. Now what do we have to find? F of minus 2. So what is it? 2 of minus 2 plus 4. So 2 times minus 2 is how much? Minus 4 plus 4, 0. So yes, this is also correct. So x plus 2 is a factor of these both given polynomials. Alright, so did you all do the second one as well? Please do not skip it, okay? So whenever, even in the exam, just read the question and understand how many you have to solve, because there might, for first one, yes, for second one also it's a factor. Yes. Alright. So very good. Next. Factorize y square minus 5y plus 6 by using factor theorem. So there is a simple way for this, okay? So first let us write, okay, f of y is equals to y square minus 5y plus 6. So how can I write 6? 2 into 3, correct? Or 1 into 6. You can just list down its factors, okay? 2 into. First now substitute 2, okay? So f of 2. What is f of 2? 2 square minus 5 of 2 plus 6. So 4 minus 10 plus 6. It's 0, correct? So if f of 2 is equal to 0, factor, okay. So if f of 2 is equal to 0, then I can tell that x, okay, y minus 2. Y minus 2 is a factor, correct? Alright. Y plus 2, y minus 3 by using splitting middle term. Okay. Y plus 2 or y minus 2, Lakshmana Prabhu? Please check, okay, it's not y plus 2. I know you can do it by splitting middle term, definitely yes. But we will check that also, okay, because here it mentioned factor theorem, so that is why I'm just showing it with factor theorem, alright. Now 3 also you do, if f of 3, so 3 square minus 5 of 3 plus 6. So 3 square 9, 9 minus 15 plus 6, yes it is 0. So yes, y minus 3 is also a factor. So how can we factorize it? We can factorize it as y minus 2, y minus 3. So it is y minus 2 into y minus 3, okay, not y plus 2. Alright, please check. Okay. So even, okay, let us check. So one of you want to check it with split middle term. Let us check. So y square minus 5y plus 6. Correct? So same thing, this can be written as 2 into 3. So y square minus 2y minus 3y plus 6. So y of y minus 2 minus 3 of y minus 2. So y minus 3 into y minus 2. That's all we got. Okay, even with the splitting middle term also we got the same thing. Okay, I hope your doubt is clear. Next, find the value of k if x minus 1 is the factor of p of x in each of the following cases. So here p of x is given this, we have to find the value of k. And it is also given x minus 1 is the factor of p of x. So first let's write p of x is equals to 2x square plus kx plus root 2. This is k. Okay. Now what do, it's okay, we all do mistakes, it's fine, but make sure you do not repeat it again. 2x square plus kx plus root 2. Now x minus 1 is the factor. So if I substitute, what is p of a? P of 1, correct? P of 1 should be equal to 0. Now substitute. P of 1 is equals to 2 of 1 square plus k of 1 plus root 2 is equals to 0. Right? Now, so 2 plus k plus root 2 is equals to 0. K is equals to minus of 2 plus root 2. Very easy. It's very simple. Alright. Next. Okay, there is also B1, right? So we'll do that also. P of x is equals to x square plus x plus k. So what is p of 1? We know that it will be 0. Why? Because x minus 1 is the factor. Correct? Now, p of 1 is equals to 1 square plus 1 plus k is equals to 0. 2 plus k equals to 0. K equals to minus 2. So in one case it is k is equal to minus of 2 plus, yes, 2 plus root 2, 1. Next one it is k equals to minus 2. Yes, minus 2 you got, very good. Correct. So this is the application of factor theorem, right? So these type of problems maybe you'll be getting for 2 marks because it's like, it's easy, but also you have to know what to use. You have to understand the question, correct? So yeah, next. Next is algebraic identities. So we are done with remainder theorem, factor theorem. You have understood because you've all been giving correct answers for the questions. Now let us move into algebraic identities. So this is identity 1, 2, 3, 4. These we have already studied, okay? Just recall. We'll just recall. So what is x plus y whole square? X square plus 2xy plus y square. X minus y whole square is equals to x square minus 2xy plus y square. X square minus y square is equals to x plus y into x minus y. And next identity is x plus a into x plus b is equals to x square plus a plus b of x plus ab. So these identities we have already studied, but just let's see and apply it in the problems, okay? Evaluate 105 into 106 without multiplying directly. So what do we have to do if we cannot multiply directly? We have to use some identity, right? So here 105 I can write as 100 plus 5, correct? And how can I write as 106? 100 plus 6. Now that I have written, I can use the identity x plus a into x plus b, right? Which we have already seen. What is the identity? I'll show it again. X square plus a plus b of x plus ab. So just let's apply identity and solve it. So here x is equals to 100, a is equals to 5 and b is equal to 6, correct? So x square plus a plus b of x plus ab. What is x? 100. So 100 square, 100 square plus a plus b. 5 plus 6 is how much? 11. 11x. What is ab? 6 times 5? 30. Right? Okay, what is 100? X is 100, right? Alright. So it is plus 1100 plus 30. So it's very easy, right? Without doing the actual multiplication, we are solving this using an algebraic identity. So let us just do this 1100. So 1, 1, 1, 3, 0. Right? Okay. Next. Factorize this. Okay, so just tell me what identity I have to use to factorize it, because you can't solve all the problem in the comments, correct? So just tell me which identity can be applied so as to factorize this. I'll just open the identities. Tell me 1, 2, 3 or 4. Which identity can be used? Okay, let us see. So 49a square plus 70ab plus 25b square, correct? So this is the given expression. You don't know, it's okay. Listen. So can I write 49 as 7 into 7? Of course I can write. So I can write this as 7 square a square plus. Can I write, okay, let us just write 70ab only because we do not get it still. Can I write 25 as 5 square? So 5 square b square, correct? Now 7a whole square, of course, right? 7 square into a square is 7a whole square plus. Can I write this as 2 into 7a into 5b? Yes, 5 2s are 10, 10 to 7 is 70, ab plus 5b whole square. Now if you observe, is that in the form x square plus 2xy plus y square? Yes, right? This is of the form x square plus 2xy plus y square. So what does it mean? X plus y whole square. So just write it in that form. 7a plus 5b whole square. Alright, did you understand now? Did everyone understand how to factorize this using the algebraic identity? X plus a into x plus b. Okay. That is for the previous one. We have used x plus a, x plus b. Wait. Okay. Alright. So now we have studied 4 identities and also applied it in the problem. TG thunderstorm. Okay, yes. Lakshmana Prabhu, yes. Very good. Now we will study 4 more identities. So x plus y plus z whole square is equals to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Okay, this is our fifth identity. Next, x plus y whole cube is equals to x cube plus y cube plus 3xy of x plus y. And identity 7, x minus y whole cube is equals to x cube minus y cube minus 3xy of x minus y. All minus. Okay. For this plus, all plus. Next, x cube plus y cube plus z cube minus 3xyz is equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Okay, I know that these are all in your textbook, you can just see, but then also learn it, okay, because you will be seeing many problems in the exam where you have to apply the algebraic identities and solve, correct? So immediately after looking at the question, you should understand what identity you have to apply so as to solve the problem, correct? So make sure that you remember all the identities and solve more problems, okay? So let us just see the application of it so that you'll understand. Okay, first is only verify. So let us verify. X cube plus y cube is equals to x plus y of x square minus xy plus y square. How do we do it? First, let us take the left hand side of the equation. Okay, LHS is equals to x cube plus y cube. Okay, now what formula, what identity I know which involves cubes, x plus y whole cube? So I will see whether I can do it something with it. Okay, so x plus y whole cube is equals to x cube plus y cube plus 3xy of x plus y, correct? So we have just studied this identity. I have just written it. X plus y whole cube is equal to x cube plus y cube plus 3xy of x plus y. Now what do I have to need? This. This is the thing I need, correct? So now x cube plus y cube is equals to, just transpose it, x plus y whole cube into, sorry, not into, minus. Yes, x plus y whole cube minus 3xy of x plus y. Correct? Easy. Now, here it is x plus y whole cube. Here is also x plus y. Can I take x plus y common? Of course I can take. So, let me take x plus y is common. And what will be left with here? X plus y whole square minus 3xy. Correct? Easy, simple. Next, let us solve this. Expand this. X plus y of, what is x plus y whole square? We all know, it's very easy. X square plus y square plus 2xy minus 3xy. You have to write this. And what is 2xy minus 3xy? Minus xy, correct? So, I can write this as x plus y into x square plus y square minus xy. Did we get the RHS here? Yes. So, hence we verified it that x cube plus y cube is equals to x plus y into x square minus xy plus y square. Okay, let's rearrange it. This. It is the same thing, I am just rearranging it. Okay. Alright. Now, did you all understand it? Because this also is one of the identities we have to remember to solve the problems, okay? That is why I have explained it in a very clear way to understand how did we even land up or get to this identity, okay? So, did you all understand? I hope you all have understood. Okay. Yes, okay. Very good. Thank you. Okay. So, yes. Next, factorize. Okay. So, 27 minus 125a cube minus 135a plus 225a square. So, we have to factorize this. So, how do we do it? Alright, let us see. So, how can I write 27? 3 cube, correct? 3 3s are 9, 9 3s are 27. So this I'll write as 3 cube. And this I can write as minus 5a whole cube, correct? Okay, next. This I can write as 15 5s. Okay, how can I write minus? Okay, let us just put minus 135a plus 225a square. Okay, are you all solving it? So please take your pen, paper and solve it, okay? So here, yeah, so here you are seeing cubes, you also have a square, correct? So what can it be? Can it be of the form x plus y whole cube or x minus y whole cube? Of course, right? So what is a plus b, x minus y whole cube? X minus y whole cube is equals to, I'll just, let's x cube minus y cube minus 3xy of x minus y. So we will see whether we can write this in that form. Why am I directly telling cubes? Because here I am able to see the cubes, correct? So I have to see whether I can write this 135a and 225a square in that format. Okay. So yes. Alright. So 3 cube. Okay. Minus 5a cube minus 3xy. So 3 into 5a. Okay, 3 into 5a is done. 3 3s are 9, 9 5s are 45, correct? And 45 into 5 is 135, right? 45 into 5 is 135. So I can write this 5a and this will be 3. Right? Okay, I'm so sorry. I have just rearranged it. Did you all understand it here? Obviously it's clear till here, correct? So 3 3s are 9, 9 5s are 45, correct? So we have to get 135a. So what does it mean? This is 3. So 3 3s are 9, 9 5s are 45. 45 into 3 is 135. So minus 135a. And how to get 225a square? 3 3s are 9, 9 5s are 45, 45 into 5 or minus 45 into minus 5 is 225. So this is of the form x cube minus y cube minus 3xy of x minus y. Correct? So we can write this as 3 minus 5a whole cube. Good. Next. Okay, we have the second one as well. Okay, this is of the form a cube minus b cube or x cube minus y cube, correct? So this you have to solve and tell me in the comments if you have solved it, okay? I will just open the x cube plus y cube, just use the formula, it's just a previous slide, okay? Just go back a little, understand this x cube plus y cube formula, just apply it here, okay? What this will be? Okay, just let me write. This will be 64m cube. So 4m whole cube minus 7n whole cube, correct? This is of the form x cube minus y cube. So there is a formula for it, apply it and let me know in the comments if you have done it. This is like a homework to you, okay? Now, so we have derived this formula, correct? That is also which you have to remember it as an identity, because as you have seen, we will be using these formulae to apply in the problem. So you can't derive every time, correct? It's also so stupid that we have to derive every time just to apply it in the problem. You don't want to solve it twice. So x cube plus y cube is equals to x plus y into x square minus xy plus y square. X cube minus y cube is equal to x minus y into x square plus xy plus y square. Right? Now what we'll do, we'll solve this, okay? I know if you are not able to solve it or if you have a doubt, let me clear this also. 4m cube minus 7n cube. Correct? So this is of the form x cube minus y cube. So just apply x minus y into x square plus xy plus y square. So please do remember it, okay? When it is x cube minus y cube, here it is minus and all these are plus, okay? Now what is x here? 4m minus 7n into 4m whole square, 16m square plus x into y, 4 7s are 28, 28mn, 28mn plus y square, 7n whole square, 49n square. Alright, it's very easy. Just apply the formula, okay? Next. If x plus y plus z equals to 0, show that x cube plus y cube plus z cube is equal to 3xyz. Now, this is one of those problems which is being asked like almost every other year, correct? So, we have to show that if this x plus y plus z equals to 0, x cube plus y cube plus z cube is equals to 3xyz, which is actually very easy. Why? Let me show you. We have already studied the identities, correct? So, what do we know? X cube plus y cube plus x cube minus 3xyz is equal to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx, correct? Now, if you remember the problem, x plus y plus z is equal to 0. So, just substitute the value 0. Very easy. Let's go back and do it. Yeah. So, we know that x cube plus y cube plus z cube minus 3xy z equals to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Correct? Now what is given? X plus y plus z equals to 0. Just substitute this 0 is equals to 0 into all this. I am not writing. Why? Because 0 into something is always 0. So this is x cube plus y cube plus z cube minus 3xyz. So this is 0. So just transpose this x cube plus y cube plus z cube is equals to 3xyz. Hence, we have showed that x cube plus y cube plus z cube is equals to 3xyz when x plus y plus z is equals to 0. I hope you have understood it. I hope you understood the entire session because this is the last problem of today's session. So, before ending it, let me just tell you the schedule again. So, 6 to 8 p.m. slot is for class 9 and we will be discussing one shot. That is, we will be covering entire chapter in one session, and later we will be doing sample papers of both math and science. Okay. Next, there is also coding for class 9th. The time slot is 8 to 9:30 p.m. where you will be studying these topics, and the dates are 2nd, 9th, 15th and 19th February. So please do take a screenshot and attend the classes because it will be useful for you as you will be writing your term 1 exam, correct? Sorry, term 2 exam. So yeah, this is it for today's session. Thank you. I hope you all have enjoyed. Please do attend all the classes of class 9. Okay? Yes.